Hi everyone, good evening, and thank you very much for joining us. My name is Janet Bedard from the Faculty of Applied Sciences and Technology at Humber College, and I welcome you to week 4 of National Engineering Month, when the Canadian engineering community comes together to shine a spotlight on engineering excellence. The theme of week 4 is engineering ethics, impact, and the future, and I'm really honored to introduce you to this online event on sustainability challenges in the built environment, hosted by the Faculty of Applied Sciences and Technology at Humber College, otherwise known as FAST. We're excited tonight to continue to engage in bold conversations and share keen insights and experiences during this annual month-long tribute to engineering. Humber College's FAST is a proud partner of National Engineering Month, otherwise known as NEM, and this year is particularly exciting for Humber College as we launch 3 new engineering degrees in mechatronics, information systems engineering, and the built environment this fall 2021. These new 4-year degree programs complement our existing portfolio of technician, technology, degree, apprenticeship, and graduate certificate programs, to name a few. Humber College is located within the traditional and treaty lands of the Mississaugas of the Credit, known as Etobicoke, the place of the alders in Michi-Saugig language. The region is uniquely situated along Humber River watershed, which historically provided an integral connection for Anishinaabe, Haudenosaunee, and Wendat peoples between the Ontario Lakeshore and the Lake Simcoe Georgian Bay regions. Now home to people of numerous nations, Etobicoke continues to provide a vital source of interconnection for all. Tonight's discussion will explore new challenges for engineers engaging with sustainability in the built environment. We invite you to stay connected, engaged with us on your social channels, including hashtag NEM 2021 and hashtag Humber FAST. We also invite you to engage with our presenters. If you have a question or a comment, please include this in our chat, and we will allocate 10 minutes at the end of this discussion to answer your questions. Now, let me please welcome our presenters. Dr. Martine Spinks is an Associate Dean at Humber FAST, in charge of the Design and Built Environment Cluster. She has consulted, lectured, and published on the sustainability in the built environment for 20 years. She brings an international perspective to her role at Humber College, having lived and worked in Europe for a number of years. She brings this experience and her international network to our applied research projects, as well as to Humber's new Bachelor of Engineering degree in the built environment.
Thank you.
Hi, Martine. And Dr. Ali Haas is the Manager of Strategy and Business Development in Mechanical and Electrical Design and Energy Management Services at WSP Canada, the recipient of the Association of Energy Engineers Canada Energy Innovator Award of 2020. Ali is an award-winning engineering leader and innovative business strategist with more than 15 years of experience in energy conservation and environmental sustainability. Welcome, Ali.
Thank you, Janet. Appreciate it.
So a warm welcome to Ali, Martine, and viewers joining us this evening. And now I invite Martine and Ali to take the virtual stage. Welcome.
Thank you so much, Janet. So I will begin. So Ali, next slide, please. And I'll just have to excuse myself. I'm not complaining about spring, but I got a little bit of a seasonal allergy going in my throat because I took my kids out into the garden right before I came on here. So sorry if I've got a bit of a frog in my throat. So the built environment and engaging it. Well, the built environment sector has a large role to play in contributing to sustainable development. So in fact, the OECD has identified the sector as a cornerstone of sustainability. The United Nations Environment Program has put forth that the global built environment is responsible for 40% of global energy consumption, 30% of greenhouse gas emissions, and 30 billion tons of raw materials used annually. Also, 25% of the total global timber harvest is related to buildings. So what does that mean? Well, actions by designers, engineers, and government authorities over the years have led to some fantastic sustainable buildings, but they haven't really been sufficient to achieve market transformation that has a significant impact on these kinds of statistics. Buildings still consume 16% of fresh water and 40% of raw materials. A large portion of this problem, though, is that progress, I think, has just been technician-led, and that the technicians have not been seen as the power base in the built environment sector. The power base tends to include financiers, developers, and maybe to a lesser extent, the occupiers who have power through influencing market demand for buildings. Now, just to jump back for a minute, we need to understand that while we have a definition of sustainable development that you probably are familiar with, that's development that meets our current needs without compromising the needs of the future generation to meet theirs. Just to let you know, there's no precise definition of what a sustainable building is. And that's largely due to the fact that traditional conceptualizations of building process, that process is really highly divisible and it's really quite siloed. Cities are home to 55% of the global building population. They account for 75% of global GDP. We have the property development and the infrastructure sector as a huge significant contributor to our GDP. And we have the effects of sustainability in the cities. So we have a divergence between the environmental impacts and market and who's the power base in the market. Urbanization is increasing. So really, what do we do about this? Next slide, please. How has sustainability been addressed in action in our built environment? We have a real legacy approach still to sustainability in the built environment that's rolled over from 20th century building process. And in this model, there's really largely dependence on science and applied technology innovations to resolve the issues of unsustainable building products and practices. So basically, everybody knows there's a problem, but it comes down to industry identified problems in the building and development process that leads to innovative changes that improve building and urban sustainability performance. I'm not going to debate the usefulness of metrics here. I would happily discuss this offline with anyone afterwards tonight. But the point is, go back one slide, yeah. The point is that over the years, the approach to sustainability in the built environment has really been led by on-the-ground technical expertise that have not often had the recognition of being the leaders in the field. There have been no breakthroughs in pure science, no radical transformation of regulation and policy. There have been incremental advances to targeted problems made by engineers and associated design and built teams themselves. And that's also a little bit of a shout out to any architects and construction managers that are in the office or in the audience. But it really is the engineers that come up with these material changes. Actions by design and build teams over the years have led to some fantastic sustainable buildings and some sustainable built environment solutions in general, but these still are not sufficient to achieve market transformation, meaning that progress is still technician-led, but they're still not seen as the power base. So sustainable building market is yet to scale up to the potential that engineers know that they can deliver. Why? Well, like in my house, when I find sticky handprints on my kids' bedroom walls, blame always lies somewhere else. Next slide, please. Here we have the built environment sustainability circle of blame. So we have engineers saying, well, we would design more sustainable buildings, for example, but the developers or our clients don't ask us to. And then we move to the land developers and they say, we'd ask more, but the investors won't pay for it. Then you ask the investors and they say, sure, we'd pay for it, but there just isn't any demand. And the occupiers say, well, actually, we would like to occupy sustainable buildings, but there are very little choice out there. And so goes on the circle of blame. Next slide, please. So into the 21st century, what should our situation look like and how can we really affect positive change? I believe that the answer lies in smart systems-based multidisciplinary engineering. Engineers are the link between scientific discoveries and the commercial applications that meet societal and consumer needs. Engineers are positioned to identify and develop sustainable building solutions from both the materials and customer perspective. They are the keystone in the innovation and delivery process. And this is a very powerful position to be in, and one that requires training in joined-up thinking and multidisciplinary approaches to team working. Engineers no longer just sit behind a drafting desk. Buildings are no longer just bricks and mortar. Sustainable buildings are multifaceted systems. the underfloor heating in your kitchen that you switched on from your car whilst you're simultaneously turning on your home alarm and checking that your automated solar shades updated when the clock switched to daylight savings hours. I mean, that's a very cool system. And that is a small scale system we're talking about. Think of the applications of taking a systems approach to a commercial building. For example, looking holistically at all the systems and how they help ensure the most energy efficient building performance to help owners and facility managers meet their sustainability and environmental goals. HVAC equipment and system components must operate together, for example, to achieve those optimal results. I worked in a building once, and it was designated the first ever BREEAM outstanding commercial building in London. 7 More London is what it's called. It was PwC's headquarters. And you would sit there and I had individual air conditioning controls, and it would come down to me, and it was cold, so cold usually in a building. Then the guy next to me, and I have to put on my jacket, and the guy next to me would have to take off his jacket because he was wearing a wool suit and he would be too hot. But when you work in a really smart building and everything is linked up, I could control my own air environment. And that's really powerful, and that has significant incremental gains. So we require a method that focuses on total system efficiency rather than chiller-only equipment. Or chiller only or equipment only optimization. So that first slide with the 40% of global energy that's used and consumed in residential and commercial buildings. So while it's important to choose equipment that delivers high efficiency performance, it's even more critical to take a whole systems approach to building design and construction. And this method puts engineers in a better position to help owners, occupiers, facilities managers achieve their goals so they can minimize environmental impacts and maximize building performance. And that's a key principle design that's distinguishing sustainable building in the 20th versus the 21st century. Building processes, so-called green building, it's not just a matter of bolting on a number of sustainable equipment features to an otherwise conventional design. A building should be viewed as a series of interrelated systems, all of which have the potential to adversely or positively affect the environment. But what about that circle of blame, Martine? Who's paying? How do you get the power base to agree with you and to invest? Good question. Next slide, please. Your client is paying. And whether your client's a private owner or company or public entity or municipal body, they're the one that will be paying. And my co-presenter will touch more on this with examples from, for example, the City of Toronto in just a moment. But for our purposes right now, you need to know that, do you have informed clients? And you as an engineer have more power in this 21st century building process to input and to inform your clients. Part of that multidisciplinary language engineers of the 21st century need to know includes project management and transactions. So a successful transition to delivering sustainable buildings has to go beyond just the science and just applied technological innovation, and also include explaining changes to traditional design and building process, right? Every step of the way, you need to have that communication, and you need to be communicating with your team and communicating with your client. So likely your clients will be very well versed in the language of time and money and how to save them. They'll probably ask themselves key questions regarding any enhancements to change from conventional status quo. Do I have something different here? Is this an innovation? Is this system regulated? Is it legislated? How difficult will it be for me to make this change and implement it? Where do the materials come from? What about the skills base to build? Will it be easier to attract investors and occupiers? Is it more expensive? And while as engineers, technically, that's not your job to answer all those questions, you should be informed about the benefits so that you can continue that dialogue to engage your client. Because if done right, sustainable building systems don't need to be more expensive. It's another example, right? A more ambitious retrofits can provide greater potential for economic environmental benefits than simply replacing one system at a time as systems reach their end of life. There was a project in the US in which it was 140,000 square foot commercial building required a new heating system to replace an old one. And replacement of the single system with a new highly efficient piece of kit would have resulted in the building owners having about 111, I think, year payback period. But by combining a new heating and ventilation system with a newly designed lighting system, which incorporated low energy, high efficiency fittings, They reduced heat gain, and a simpler system allowed significant reduction in mechanical ventilation systems. So instead of replacing the old one, just the heating system and instead replacing it with the whole system, heating, ventilation, and lighting, then the payback period was only brought down to only 2 years. And it was successful because the solution addressed the whole system. Next slide, please. So just to touch on what Jan had said before, at Humber, we're rolling out this new Bachelor of Engineering degree in the built environment. This fall, 2021, will be the first intake. And we offer it uniquely with this common first year that really mimics this real world multidisciplinary team working. And this kind of engagement and bringing not just built environment students together with themselves, but they're coming together with mechatronics and ICT, because that is 21st century engineering. It is working together on the systems, understanding multiple perspectives, and innovating within the system. Within the built environment engineering degree, we offer 2 specializations when they come out of their first year: sustainable building and building information systems. And that was done because we went to people like Ali and said, what do you need? What's lacking? What can we do to help make this better? And we developed this approach and this curriculum together to really plug that and to create a new 21st century building process. Next slide, Ali, over to you. Mute.
Thank you, Martine. It was super informative. Something I wanted to touch on today, and we want to open up for the QA at the end of the day to make it more interactive, and as much as we can, we want to address your questions. So what I want to present today is, first of all, so everybody, we have a different concept of what sustainability means. I think it is very important to set the foundation about what sustainability means, what aspect of sustainability, and then I want to touch about specifically in the built environment and the application of the sustainability in the built environment. What is the life cycle for building design and engineering specifically? And I want to walk you through a very a practical example of application of sustainability for municipalities. So we are working for City of Toronto to design and develop policy strategy to help City of Toronto to achieve their target to achieving net zero by 2050. So I want to basically provide you examples about the different aspects and the thought process required for developing the program, designing the program, and helping City of Toronto to map out the next 30 years of implementation. So basically, you're going to get a good understanding about what sort of qualification skill set you might be interested in and require to design and implement sustainability project in built environment. So first of all, sustainability is not climate change. It's not all about the climate change. So I want to make it crystal clear. So sustainability mostly has 3 pillars. It is all about environment, it's about social responsibility, and it's about affordability. So it should be for a very good sustainable design project, you have to have a sort of a balanced approach to make sure you're not only suggesting a very innovative and progressive solution to the market, but you have to make sure from the social responsibility perspective, so you're allocating your resource uniformly throughout the society or in this case, the City of Toronto. As well as you want to make sure you go to the extent in terms of implementing technologies, that the technologies and implementation is cost effective and is affordable, or during the life cycle of the projects is going to be affordable and competitive. So this is very important to look at it. And I would suggest if you really want to develop your skill set specifically in this market, instead of look at the mass media like TVs and news agencies, go to the universities, go to the colleges, go to the professors, and really understand the concept of sustainability, and come to the industry. So we are dealing on a daily basis on a different type of problems, working on a different service line, trying to amalgamate and create a sort of uniform solution in the market. So please reach out, and we are happy to help you to really understand what is going on and what are the practical solutions. Okay, so let's talk about building systems and building life cycle. So I don't want to go through all the sort of steps, but you want to know that for both existing building and new construction buildings, you have to go through a design process. So you have to go through the construction, commissioning of the technologies and equipments, and thereafter is a period of the warranty, and mostly in the contractual process is a kind of dispute resolution in terms of what was supposed to be designed and what is implemented, which is very important. And thereafter, the building is constructed, the equipment is operating. You're going to the sort of a maintenance and operation of the building. So 3 important factors in the whole process, in the whole building system and their life cycle is client support, problem solving, and project management is the continuous effort. So it started from the get-go, from the start of the design, and it's going to go to the end as long as your clients need support. So at WSP, basically, when you want to talk about sustainability, it is not about the concept of sustainability for today. It is for tomorrow, for next generation. And based on the policy, each municipality, each government is imposing, you need to understand what was coming down the pipe. So in WSP, we introduce a concept of future ready, which basically touch on climate, society, technological advancements, and resources. So we have a limited amount of resource, we have a limited amount of labor, we have sustainable development goals developed by United Nations. And the main important question is, so because the resources are not infinite, you have to have a priority, and you should adapt a really balanced approach in terms of implementing your solution in the market to make sure your solutions you're getting the most impactful results from your strategy and from your design specifically. So in City of Toronto, let's talk more practically. City of Toronto in 2017, they started talking about the Transform TO. So Transform TO was a kind of policy strategy implemented by the city, touching all aspects of a living in the City of Toronto, which building is one aspect of Transform TO policy. So they're talking about a sort of a long-term goals for the city to achieve, like 65% reduction in community-wide GHG emission reduction by 2030, which actually in 2019 became more aggressive, and the new policy introduced that okay, you need to achieve basically 80 by 2050, and even nowadays net zero by 2050. So I don't want to go through all the policy strategies suggested, but there is a sort of for the built environment application. So you need to think about the new construction buildings, which basically following the building code in Ontario and in Canada, which happen to be renewed more frequently. But for existing buildings, we don't have a sort of a very structured and organized code in terms of how building is going to operate, how existing building going to be operated and maintained over the next couple of while, like 30 years for 2050 targets. So the whole question was about, okay, now we have existing building code and Toronto Green Standard for the new construction building. So which is basically is a tiered approach suggesting how building going to be performed based on the suggested standards. But for existing building, we got engaged to develop a sort of a tiered-based standard to make sure the existing buildings going to be retrofitted over the next couple of years. So let's talk about more specifically about what it means like transform TO and what we want to achieve in terms of moving forward. I think if you look at the sort of a 2020 target, which is like 19 million ton per year of GHG emissions. So the projection, if we do nothing and as a sort of the business as usual, if we move forward by 2050, so we're going to have about 14.1 million ton per year of GHG emissions. But based on the 2050 target, so we have to reduce our GHG emission by 5.4 million ton per year, which is a sort of about, we have about 9 million ton of carbon emission per year of a gap. So if you look at what the gap is coming from, so the gap could be addressed through a couple of like approaches. So electric vehicle, community energy planning, district energy systems, and improved building energy efficiency. So the big portion of efforts needs to be allocated time and effort over the next couple of years is improved building energy performance and efficiency, which drastically going to help City of Toronto to achieve their target by 2050. So what is required? So if we really want to achieve our target by 2050, what needs to be developed? So basically portfolio level programs, policies for commercial facilities specifically do not exist at the moment. So in such a structured manner, but especially for large commercial owners, managers, there should be a sort of, we have nowadays a sort of voluntary approach like BOMA, BEST certification, Canada Green Building Council LEED certification, and most recently we have some certification for buildings, which is not mandatory, but promoting health and wellness in built environments. So basically something we look at it as majority of our emissions. If you look at the Toronto greenhouse gas emission 2017 data point, so 52% of the emissions coming from the buildings, 10% is waste, and 38% from transportation. And specifically, if you look at the GHG emission by building types, so 36% of GHG emissions produced by commercial and institutional, 13% from industrial, light industrial buildings, and 51% for residential. And specifically in Toronto, if you look at the energy source, so we have natural gas and we have electricity. So the electricity market in Ontario, so which we are lucky, is about 85 to 90% clean electricity, about 60% coming from the nuclear generation, about like a 35% on average coming from the hydroelectric, and the rest coming from wind. And we have a natural gas generation, which is mostly using in peak hours when we need electricity the most. So in order for City of Toronto to reduce their emissions, so we needed an approach to make sure we are reducing our natural gas consumption, or substituting the existing fossil fuel-based natural gas with renewable-based natural gas, or contemplating electrification on a hybrid. So the challenge was basically, we call it a spark spread between the price of electricity and the price of natural gas. So in order for you to heat your building, natural gas, we have the infrastructure and it is cheap. So we are like a 20 cents per cubic meter. But comparing if to the electricity, and nowadays the electricity is much more expensive if you really want to follow the electrification policy. Okay, so to design the existing building emission strategy for Toronto, what needs to be done? So we have to achieve deep emission reduction across the building sector. So we have to develop a policy that touch on residential, commercial, and industrial. We have to support the building industry in making transition to low carbon sector and support the realization of multiple co-benefit in, as I mentioned, this is the sort of the sustainability pillars. It is not all about reducing GHG, but we want to analyze the economic impact. We want to make sure we are basically contemplating the social responsibility and social equity, about the resiliency of our buildings, and about nowadays, with the pandemic, everybody understand the other aspect of operating a building, which is basically health and wellness of the tenants. So the policy strategy we put together, we started about a year ago. So what was the tasks, the major tasks we identified in the process? We realized we need to create, so in our policy strategy, we have to create a comprehensive package of policies for the City of Toronto to support all the building sectors to reduce their emissions, and understanding a pathway for implementing the suggested policies. So we have to create a framework that make sort of some mandatory emission performance standards for existing building, like what we have for new construction building, which is following the overall policy suggested in Transform TO. And we have to find a way in order to make these policies to be practical. We have to make sure we are not creating a sort of a pathway that is not cost effective and put a lot of like a cost burden on people living in the City of Toronto. So it was a sort of a multi-variable problem. So we have couple of objectives and we have a couple of variables, and we have to optimize what is the best way to tackle this problem. Okay, so what was our approach and what was the key deliverables? We want to make sure we create a framework which we basically define the targets for different archetype buildings in Toronto. We create a policy that support implementation of different technology, and we also provide like support to the building owners and operators, making sure first of all they understand the guideline, and we are helping them to be compliant following the guideline and standards. So it was basically something we are suggesting here. You can see like the whole implementation of a sustainability project as an engineer for very high profile clients. It touches not only on technology, not touches on engineering design, but you have to understand the impact of what technology you're suggesting from the economic perspective and from the social perspective. So the framework we develop, basically, we have like a 4 steps, 4 phases. So startup, we basically went to the market. We did a sort of a market sounding exercise, and we engaged with the stakeholders in the market, from the building owner, operators, ESCO contractors, engineering designers, to understand the best practices, industry best practices. So we screen whatever policy has been implemented nationally from Vancouver to East Coast in United States, and best practices in Europe and even Australia. So the next phase is basically we wanted to make sure we are creating a sort of be providing background information to the marketplace that why we are developing this policy and what would be the impact in the market, both for the City of Toronto as a client and for the stakeholders, which basically the public living in the City of Toronto. And the framework we developed basically talking about targets, policies, and how we are going to be engaged with the market. And then the last phase was talking about how we are going to implement whatever suggested technologies and policies, and what are the priorities. Okay, so when I'm talking about the policy, I'm not talking about the policy the way we understand like about the government and politics. Basically, the policy includes requirements in terms of how building being operated and being renovated. We are talking about what sort of incentive and financial tools going to be provided to the stakeholders, and what kind of engagement and promotions going to be implemented in the marketplace that promote the whole mentality of achieving a net zero by 2050. So the requirements includes mandatory benchmarking and reporting, renovation, the time of sale renovation or time of tenants renewal renovation, developing a retrofit code, developing a performance targets for different building types, and talking about the fossil fuel bans. Not a bans is a strong word, is a sort of transitions to more clean energy source. Talking about the zoning requirement, permit requirement, which is basically touching about the actual engineering design. And we want to make sure we're touching on not operational carbon emission, but also about the embodied carbon emission and reporting and requirements. So incentive and financing. So what kind of financial tools we're providing to the market? So it's going to be like a funding, it's a retrofit financing, it's going to be a tax exemption, it's going to be an incentive or rebate, or it's going to be a sort of a green bank, green leasing program, like a cheaper financing for retrofit projects, or many other alternatives. So we contemplated in terms of how we are developing our policy strategy. And last not least, talking about the engagement promotions, we basically wanted to understand what sort of educational program we have to develop, who needs to be involved from the industry perspective, and how we are providing the advocacy and training required. So if you look at the sort of three segments, you look at it if you are like a recent graduate, or you are you want to develop your profession, your job in the future as a student, or as somebody contemplating to basically pursue sustainability in the long term, you see a lot of different aspects and angles of sustainability in built environments. So in terms of requirement financing, I don't want to touch on this, but basically, so you can work in sustainability as an engineer. You can work in sustainability as engineers, understanding the law and financing aspect of the projects, understanding construction law, or you can be engineer advocating for trainings and engagement in terms of what policy going to be implemented. So something very important here that we have to recognize is the effectiveness of achieving emission reduction basically is predicated upon the ability to rapidly scale up. So we don't have like the luxury of infinite amount of budget or time. So we have to anticipate cost to stakeholders. We have to do co-benefit analysis and understand the risks and liability. And we have to have the ability to implement this policy strategy in different cities, jurisdictions, contemplating about social equity and accessibility to financing for all the stakeholders, all buildings owners, industrial, commercial, residential. So in this graph, so this is basically a very rudimentary kind of visualization of what transformation of City of Toronto and the retrofit market for existing building going to be look like. So we are going from a sort of a voluntary approach to implement a mandatory approach in the City of Toronto, which is you're going to see in the next decade or so, to engaging with early adopters, with enthusiasts, and with people really cautious about the environment, and moving forward by basically adoption of technology, advancement of technology, and making technology more cost effective, organically or through policy. We're going to have all the regulation being mandatory implemented in City of Toronto. So this is the only way so we can make sure we're achieving our net zero by 2050 targets. So key retrofit actions, if you really talk about a specific engineering aspect of the policy strategy, we developed some two approaches, like inward focus, outward focus. The inward focus talking about performing energy audit, retro commissioning, continuous commissioning, implementing like an energy management system, benchmarking, as well as like the outward focus means like instead of doing some engineering projects in the building, we want to talk about labeling and reporting, talk about sector advocacy, and we're talking about the training and voluntary standards. So on top of the approaches we can contemplate moving forward with, we have to think about the different technologies like fuel switching, on-site renewables, deep retrofit, or talking about the space heating in a using different sort of form of space heating, or utilizing district energy systems, which is very prominent in Toronto, considering the vastness of N-wave network and what would be decarbonization going to be look like for the City of Toronto by having a massive district energy system in place in the financial core for the most part. So this is, I want to share you, like this is not a specifically realistic numbers because we are under confidentiality in terms of we are not going to, I don't have authorization to give you the actual numbers. The report we produce going to be published in the next couple of months by City of Toronto, and you can look at it. But I want to give you a sort of a perspective about, so what all the sort of a discussion about the policy, technology, like a economic aspect of the different type of projects we are contemplating going to be translated into the actionable items. So first of all, you have to do scenario analysis, you have to do sensitivity analysis, but as part of the impact assessment, if you look at it here, so we have a different sort of, we created a baseline. So how much GHG emission we are producing. And we created sort of a baseline for our GHG emission as a status quo. And moving forward, we are talking about a different implementation of different technologies or policies. And we are basically quantifying the impact on reducing our carbon footprint. So based on basically the graph you're seeing, so we are talking about sort of a different technology. It is not only, we're talking about the capital investment or CapEx projects, we're talking about the operational improvement, behavioral change, which is which is one of the main consideration in this policy strategy we developed for City of Toronto. So you can see implementation of solar PV and their impact on reducing the GHG emission, LED lighting, low-hanging fruit, like replacement, or going to the more like a deep retrofit projects, changing the envelope, improving your heating system, or going to fuel switching and electrification. So by looking at the impact of the different policy, we are going to basically look at it, how we're going to go give priority to different technologies. I don't want to spend a lot of time on this slide. So basically what we've done, we'll look at the individual different type of buildings, and we categorize them. We create a module. We did like a massive simulation running for a couple of years to produce results, to understand what are the total impact, as well as what are the attributed total cost for implementing the specific projects. So if you look at the Toronto GHG emission, so this is a sort of a preliminary kind of results we produce along the way. So you can look at it like from 2017 to 2050, if we want to achieve net zero and reducing our emission. So there are different pathways. Based on different pathway, we're going to have different cost impact and different social impact, and different policy requirement to make sure we are achieving our targets. So to wrap up, so a couple of recommended policy and actions. So you're gonna see in the next decade, in the next couple of years, a couple of them is a low-hanging fruit. It's gonna be super speedy to implement, but a couple of them is gonna be a longer-term approach. So you're gonna see sort of basically a mandatory annual performance reporting and public disclosure for all type of buildings in Toronto. You're gonna see we're gonna establish emission performance target for different building archetype. You're gonna see a mandatory recommissioning and tune-up required for a building every couple of years, and you're gonna see basically the different technologies in order to be cost effective going to be bundled together to make sure it's going to be practical and cost effective. And we have a sort of a list of like I have 9 items here, but it is much more than that, and we want to make sure. So hopefully I gave you some idea about like how a very considerably big sustainability projects going to be implemented, and what aspect we need to consider when we are tackling sustainability projects. Okay, so I think I'm done. So I don't know how we are going. We are going back to Janet. Probably we're going to open it to people to ask questions. I don't know if you're going to make it a sort of like they can write the questions, or we're going to turn on the camera. I'm not sure.
Yeah, I think what we'll do now is Janet's had to leave. She has many small children and animals, so she had to go. But let's open up to some questions. There's a question in the chat from Maha. What simulation is recommended? Maha, maybe you want to, I'm not sure if you're still there, to unmute yourself to elaborate upon your question.
Okay, I think I can answer that question. So the accuracy of simulation and doing the energy model depends on how much money you want to spend. So one of the challenges we had is the massive number of building needs to be modeled, and we have access to a different type of energy modeling software, from Rediscreen to eQuest to Energy Plus. But the whole concept was, okay, what is the required accuracy to create the overarching policy and not getting lost in the weeds and make sure whatever we are developing is accurate enough, but is not too expensive. So basically, we went through a couple of iterations with City of Toronto to have a consensus around like what accuracy is required and acceptable. And based on that, we basically adopted a process to do our energy modeling.
Are Beaumont or LEED accreditations rewarded with grants or rebates? No. Okay. Rebates.
Okay, I didn't understand the question, Martine. So what is actually like do
you get a rebate? Nick, do you get a rebate if you hit, for example, a platinum? No, Carrie, or Carrie. Ali, do you know, or I was going to shout out to an attendee in our audience, Carrie.
Sure, if I understand the question correctly, so City of Toronto needs to be agnostic in terms of promoting different certification paths. So we have to make sure if there's any rebate going to be provided to the public, it is going to be uniformly distributed and is not going to be sort of creating a monopoly of certification. I think like in this policy we developed, it is a more of the performance-based strategy comparing to if you achieve a specific certification, you're going to get a rebate. I think there are multiple platforms. The energy performance going to be tracked like Energy Star and Energy Portfolio Manager. So the actual performance of the buildings based on their actual kW hours reductions or natural gas reduction, which could be translated to the GHG reduction, going to be considered if there is any like a rebate going to be provided to the public down the road. But the whole idea is like in Ontario, over the past 10 years, we have been providing rebates for energy efficiency projects through the Save on Energy program, which being managed by Independent Electricity System Operator of Ontario and majority of the utilities up to 2017. I think that the market, specifically when we look at the more advanced market like New York and California, the whole notion of rebate is being outdated. And the impact of the rebate, it is very hard to be estimated or calculated. I think the benefit needs to be seen and achieved through the actual building performance. And for that reason, if the technology is cost effective, it is good for you in terms of the energy cost saving. It is basically you're going to follow the policy, the mandatory GHG reduction. And as well, nowadays in the marketplace, all the tenants asking for sustainability metrics. So basically in terms of the leasability of your property, if you're a commercial building owner and operator, you want to basically be proactive in terms of implementing those kind of technologies.
There's a real part of my research that I've done is on the imageability of sustainable buildings as an investment incentive. So to be seen to be sustainable and seen to be in a sustainable building as part of recruitment and retention of employees in that building, or selling the home as a market, a distinguishing feature for corporations and market competitiveness. These are important factors too. Are you a fan of the of sustainable building rating systems like LEED?
Oh yeah, absolutely. So CAGBC in Canada, they have provided like a LEED certification for a couple of years. I think everybody, even like a building operators, although there's a competition in the market, so that competition is good from the sustainability perspective. And then you look at like myself. So when I was trying to find a place in Toronto, I was looking at okay, this is a LEED Gold certificate or LEED Silver, because at the end of the day, certification is not a matter of certification. The certification translates to your utility cost. and translate to your carbon footprint.
I have a quick funny story. So I had a group of students, and there was a building, and it was BREEAM excellent, and they couldn't understand why it was so far exceeding its energy targets. Like it was crazy what it was designed to do. And when they came to the operational assessment, the actual energy output, and they couldn't understand why it was happening. What it was that it had a motion triggered lighting system, and the students deduced that the security guard walked up and he went through every single one of those floors every 45 minutes. So the lights stayed on in the building all night long. Just like something so simple like that.
Interesting, very interesting.
We have Marilyn. We talk often about costs just focused on dollars. Is there a policy development that might include counting of externalities and total costs, such as carbon of proposed solutions or low carbon solution versus higher carbon solutions?
Yeah, absolutely. So we didn't look at the cost from the capital cost perspective. We included the life cycle cost of different projects and different measures and carbon reduction measures, as well as energy efficiency measures, and basically compare if the building move forward with the status quo, business as usual. So what would be the cost of maintaining a building for next 20, 25 years, comparing to the fact if you're implementing more sustainable solution in the building, what would be the incremental cost and what would be the incremental benefit. So we've developed a sort of a cash flow net present value to make sure the solution is going to be suggested it is justifiable from the economic perspective. But anyhow, I think something we have to, so I'm telling all my friends and colleagues and peers in the market. So achieving sustainability target is not free. And we have to all accept the fact everybody needs to contribute and everybody needs to follow the policy and a strategy and mandatory guideline to make sure we are creating a beautiful future for the next generations and generations to come in Toronto.
Ellie, do you see that switch when we're talking about these higher costs? Do you see that switch being something that will be picked up naturally by companies, or do you think that regulation is the stronger driver to enforce that?
Regulation required because specifically the challenge of the price of natural gas and the price of electricity, specifically in Ontario, this is a challenge. The other challenge is most of the carbon reduction projects needs to be bundled with energy cost reduction measures to be economically feasible. Otherwise, it needs some sort of it is not justifiable cost perspective. Like you just want to make a passive house, for example, it is not justifiable. So you have to make sure you're putting a mandatory requirement that basically push the market for better adaptation. Something like, for example, carbon pricing. So we included projection of the carbon pricing in the next 20 years, which is going to be like being capped at $170 per ton. So taking into account the price on carbon helps the economic of the project, but still we need more and more policy to be implemented.
Thank you. Are there any other questions? Let's take one last one because I'm conscious of the time and it's just 7:30 now. George asks, could you comment on the use of LCA software for green building, namely Athena's eco calculator that deals with the different building materials?
Okay, that's a very, very technical question.
Yes.
I've not personally worked with eco calculator, but I know there are some like the different type of LCA softwares available in the market. I cannot comment on that specific software per se, but there are different softwares. They have different assumptions. I think like at the end of the day, hopefully in the marketplace, we are going to see a sort of a platforms that are talking together and having a sort of a set of unified assumptions for calculation of the life cycle cost and emissions.
maybe maybe somebody in the audience is familiar specifically with that one, and they want to input into the chat. Otherwise, our time is 7:30, and on behalf of Humber College, I want to thank everybody for coming, especially our wonderful guests, Dr. Ali Haas. Thank you so much, Ali. I think it was very informative. We got lots of really great questions here. And if you agree, Ali, our emails are at the front slide, and we're available to be contacted, and feel free to reach out and to connect with us after this and get in touch.
Perfect. Thank you, Martine. Appreciate it.
All right. Well, thank you, everybody. I wish everybody a happy Monday, just the start of the week, but it's going to be a beautiful one. And stay safe.
Thank you. Thank you all.
Thanks, Ali. Thank you, everyone. Have a good night.